Hello and welcome to this lesson on relative charges of subatomic particles. Today, we will break down the relative electrical charges of subatomic particles such as protons, neutrons, and electrons. We will also discuss why the number of protons in an atom is crucial for identifying the element. And finally, we will see how atoms achieve electrical neutrality. To understand the relative electrical charges of particles within atoms, let's start by looking at the three main subatomic particles: protons, neutrons, and electrons. Each of these particles has a specific type of charge associated with it. Protons have a relative charge of +1. They are positively charged particles and are located in the nucleus at the center of the atom. Neutrons have a relative charge of 0. They are neutral particles, meaning they do not have any charge, and they are also found in the nucleus alongside protons. Electrons have a relative charge of -1. They are negatively charged particles and orbit the nucleus in regions called electron shells or energy levels. Here's a table summarizing these relative charges. All atoms of a particular element have the same number of protons, and it is this number of protons in the nucleus that defines the identity of an element. This number is called the atomic number. We can find the atomic number of different elements by looking at the periodic table. This is the copy of the periodic table which you will be provided with in your exam, and we can find the atomic numbers at the bottom of each element. For example, we can see that hydrogen has an atomic number of 1. This tells us that every hydrogen atom has 1 proton. Let's look at another element. Every helium atom has 2 protons. This means that it has an atomic number of 2. We can also see this on the helium element on the periodic table. Since the atomic number is unique to each element, it distinguishes one element from another. It's by knowing the atomic number that we can identify and differentiate between various elements on the periodic table. In an atom, the number of protons is equal to the number of electrons. This balance ensures that the positive charge from the protons cancels out the negative charge from the electrons, making the atom electrically neutral overall. For example, if an atom has 3 protons, it must have 3 electrons to remain neutral. If there are more protons than electrons, the atom as a whole will be positively charged, and likewise, if there are more electrons than protons, the atom as a whole will be negatively charged. We will discuss such particles in much more detail when we look at positive and negative ions in later lessons. As an extension task, let's explore the discovery of subatomic particles and their charges. J.J. Thomson discovered the electron in 1897 and identified its negative charge. Later, Ernest Rutherford and his colleagues discovered the positively charged proton in the nucleus, fundamentally changing our understanding of atomic structure. To conclude, in today's lesson, we delved into the relative electrical charges of particles within atoms. We discussed the 3 main subatomic particles: protons, neutrons, and electrons. Protons, carrying a positive charge, and neutrons, which are neutral, are located in the nucleus of the atom. Electrons, with a negative charge, exist around the nucleus in specific areas called electron shells. This gives us the following summary of relative electrical charges. We emphasize the significance of protons in determining the identity of an element. The number of protons, also known as the atomic number, is unique to each element and defines its position in the periodic table. This atomic number is crucial because it not only identifies the element, but also determines its chemical properties. Furthermore, we explored how the overall electrical neutrality of atoms is achieved. Despite having positively charged protons and negatively charged electrons, atoms are electrically neutral because the number of protons equals the number of electrons. This balance ensures that the positive and negative charges cancel each other out. This foundational knowledge is essential for further exploration of atomic structure and the periodic table in chemistry.